All right, some of the sort of more exciting things where the rubber actually meets the road. And what we try to do here for you is give you an idea of how the customers are looking at the product, what kind of pain points they have, a little bit of insight of how they look at the product, how they think will best fit within their environment, and where they made the decisions to actually start deploying the technology itself. So first and foremost, we've seen a lot of traction in discussion about what to do with the cloud. I got a couple of data points. It's the marketing section, so I have to at least throw out a couple of quotes and stats. TechTarget is one of the first of two that I want to talk about. Just did a recent survey this year. The top thing, the top goal initiative that's in most of enterprise, 48% of the respondents said it's how am I going to use the cloud? When we talk to the customers, they're like, well, we know it's there. We don't know how costly it is. We know it's kind of cheap. We can move things up for free, but then after that, that's where we're going to have this experience, what's going to happen, and how can we monitor that and manage it, but make best use of it. Secondarily, Gartner also, they just had a recent summit. Interesting little stat. Normally I always quote like, geez, how much data has mankind created, since the dawn of computing, right? And there's all these estimates, and the numbers are getting quite big, right? It's more than doubling about every 2 years. And I think by middle of next decade, we're like at 148 trillion pieces of data. It's kind of nuts, right? What's interesting is today, when we look at use of cloud, it's the Pareto, the old 80-20 rule. About 80% of the data is staying on site. About 20% is being moved up to the cloud, mostly because I think that either the applications are aware of how to actually put that up there. People don't actually have the knowledge of what to put in the cloud. If someone in IT were to make that mistake, and that data wasn't available, then the phone calls start going off, and the cell phone messages start coming across saying, "Where's my data and why am I down?" But essentially in about 4 to 5 years, it's gonna flop, right? We're gonna see a reciprocal of that. We think, based on what we see, that same Pareto rule of when you take a look at storage that's deployed today, 80% of it is cold, not used very much. Right, no matter what type of store it is, right? Give it enough time, it cools off. How do you move that off without affecting with that, the infrastructure and stopping that application? So we think that trend is going to go in the right direction, making best use of that cheap and deep. So let's start talking some of the verticals. Last time we were at Storage Field Day, we started seeing some really good traction in the media and entertainment space. We're going to talk about 4 total different verticals that we're seeing success in, and we're engaged with customers that have already sold the product. Media Entertainment's the first one. This is going to be focused mostly on the cinema, digital cinema production and post-production development. The next one is in oil and gas. I'll give you some really good insight about what these customers are doing and their business and sort of the markets, but I'll tell you, this industry is split up in sort of 2 major chunks, the upstream side and the downstream side. We're going to talk about upstream. Where they're doing exploration, where they're trying to figure out where to drill a hole in the ground or drill a hole 8,000 feet below water. These are very big, challenging efforts. And from a perspective of the geoscientist, trying to make a decision as to, should I lease that land? I only have so much time to do it. When I do it, where am I going to actually do the drilling itself? Third is the information and communication technology, aka just the service providers, right? We're actually having some very good traction there. Douglas actually hinted to many of the types of new features that we're bringing in our 2.0. Every time we've come and talked with you, one thing's been very consistent. We take customer feedback, we turn it into usable features in the product very quickly. And that's what you're seeing. You're going to see some of those results in these verticals. The last one we're going to do is EDA, really from the semiconductor chip design side of it. Each one of these has very different use cases. It makes very unique use of our technology. Same product in each and every one. Well, let's kick this off for media and entertainment. So
just out of interest, so how long does it typically take you from coming up with an idea or agreeing that a new feature is going to go into the product to the point where it's actually ready for customers to use?
I might turn it over to Douglas. It's always a matter of prioritization, right? So we have a whole laundry list of ideas that customers have given us, and we see a path to go get that done. Small company trying to get our business going, right? So we have to make sure that as we're delivering these things fully, it's reliable, right? It can go into production, right? And we can turn these features on. We do have programs, by the way, where if you're an early adopter, we can get you code drops that will give you a preview, right? And you'll put it into a test environment, beat the hell out of it and say, nope, that didn't work very well. Could you please do this or do that? I would say the cycle's pretty short, relatively speaking.
It can go from literally 2 to 3 days to several quarters if it's like a major feature. I'll give you an example for the service provider market. They came in, we're delivering to a release to them. They came in and asked 2 days before code complete, we need a custom directory reporting for capacity reasons. You know, they're like, their chargeback was the fact that they need to be able to, not from a share level, but any directory in the system they will be able to do a report on. And I'm like, well, you can just do du-sk on the client and you're good to go, right? Well, it's like, well, yeah, but that's going to suck because I'm going to be doing this tens of hundreds of times. And so I talked to my file system metadata engineer, and he's like, well, you thought about it. The next morning it came up with a new interface, what we call the Shadow Namespace, where you can do this inside a metadata engine and expose the results. Not only how much capacity, how many files there is and so forth, but also on what tier of storage every file is. And you get this about 4 to 5 times faster than running a DU. So I mean, that's something you'll see us exposing in a product. This is CLI only, it's just a REST API. But they get exactly what they want back. So from their perspective, they say, this directory is important to this department or this guy, and I can see exactly what tier of storage he's running on, and at the time of running the command. And that one ended up being just 2 days of work. There are others that are much longer than that.
Yeah. It's an amazing engineering development team. The benefit that you're hearing about is this team's been together for a couple of years now. Very tested, has a reliable platform and architecture that allows them to make these changes, and to do so without really disrupting the hardening and reliability of the product itself. Douglas mentioned before, we take enterprise and mission criticalness very seriously. This is a top-down play for us from a business perspective. I'm already going to forewarn you, as we go through each one of these customer case studies, you're not going to get the name. These are Fortune 500 companies. This is not consumer level or SMB, low-end, SOHO or robo kind of customers where we can sort of drop a name. These are big multi-billion-dollar companies that, for one thing, are deploying these types of technologies as a distinct advantage in their space. And when they roll these things out, they will have advantage over their competitors. And we've run into this many times as we bring a brand new technology, something that is, and I hate to use the word, but it is disruptive. When you can figure out how to turn it into, and when we talk about the service provider, we're going to give you some interesting turn of events. Their implementation, they stop thinking about the technology. They start thinking about how can we take advantage of it? How can we change our business model, improve our gross margins? How can we offer new differentiated services? That's when it was getting to be fun. You just watch this whole group sort of light up and say, okay, wow, we have no more limits of dumb applications. Now we can make them aware. Now we can start helping making some choices. So we'll show you what we're going to do there. Let's dive into the media entertainment real quick. But this is on the cinema digital post-production side of it, right? So you're capturing raw data off of these high-resolution cameras. The first sort of encounter, this is from 4K resolution, right? And we're not really talking about the consumer side of this stuff, right? It's sort of the 4K by 3K by 10-bit RGB kind of frame sizes and capacity, right? So we're talking in the neighborhood of like 50 megabytes per second per frame. And if you're doing like 24 frames a second, right? Not consumer, sort of 30. But even if you did like 3D, you got to double that up, right? So when you start talking about processing these things in real time, you start getting some performance challenges, right? So the amount of capacity you need, but the amount of performance you need. So there are things that they have to do to try and overcome it. They want to stay in native mode. Whatever's coming out of that camera, whichever model of camera and manufacturer, then they're all slightly different, right? So where the product ends up and how they sort of project it in a theater and how they transform it into, say, like a Blu-ray or on a high-def 4K for consumers, all very different because a lot of compression technology is thrown into it. But what they don't want to do is they don't want to have to put some compression technology on it so they can actually fit it through the pipe and get 24 frames a second. So that was one of the first things that they asked about. How can we actually scale the performance of what we've got? The second one was even more interesting. So Douglas mentioned about we've had a lot of capability for offloaded cloning and snapshotting. Snapshotting, if you can do your snapshots, move that snapshot to a different storage device in a different location, is now officially a backup. Right? So no one's really doing traditional backups anymore. Snapshots are very convenient for doing that. But one of the limitations is I can only take so many snapshots so often. It fills up my storage. Now I have to do it at less resolution. But what if we could actually move the aging snapshots off and keep it? So they have now backups of daily edits, daily changes, daily renderings. These are the things they were asking about. And we consistently see that in this industry. So we went into our first set of customers. They would deploy Isilon using Smart Connect, using 10 gigabit links. But they had a challenge. They're telling us, like, look, we have 10 artists, and only about 3 or 4 of them are really productive. The other ones are waiting for their storage and waiting for their renderings to finish. And basically what's ended up happening, what we find out is that when a client is mounted, it's a single mount point into this cluster, that single share point is in fact the limit for them. They basically 10 gigabits of performance as long as there's no other client being mounted to that same share. So now they have to go figure out, okay, well, I guess I have this nice cluster for performance, but I'm not going to be able to get full utilization out of it. So they asked us to figure out how to solve that problem. Second one is, with their capacity limits, how fast could we take and move snapshots? So what we did was we give you an idea of how we sort of approached it. We took these features that we've talked about today. We take DataSphere, we can take a set of Isilon clusters, or a set of Isilons, and we can cluster them under our space. And then we can load balance on a per file basis. And that's what ends up happening. We take a look at what is it's physically happening. This is what the customer's dealing with now. When you can take those 24 frames per second and sprinkle across a number of Isilon storage arrays, we can now actually pull them all in parallel, and they can actually get more 24 frames per second of full 4K on their existing storage and support more simultaneous artists and rendering activity. That was a big opening for them. And the next one was, what happens with snapshotting? And so in our case, they may actually have multiple tiers now. They may have their hot tier for the highest level of performance, low latency. They may have a warm data tier. We can actually start taking these snapshots. And as you know, if from an objective perspective, you can actually say, look, after the third snapshot, I want you to take and move the oldest one off into the cloud. Give me some more room so I can continue making more snapshots. This gave them granularity that they couldn't see before. They can do it, but they'd have to throw a lot of storage at it so they can keep those snapshots local. And if they need it, it's easily returned back just on demand by accessing it. You don't have to do anything else. All right, let's go to the next one. Oil and gas.
Hey, Lance,
Yeah.
for a second. Can you go back to the slide before this one?
Yeah.
So they had, let's say, 4 Isilon clusters. Is that how I would read
Yeah.
that? And you were able, and what was happening was one frame clip or one file clip was all coming out of one cluster?
One stream, yeah, one stream of 24 frames per second.
And you were
out of
able
a
to
single
take
cluster.
those and split them across multiple clusters?
And load balance that across the available nodes. And I think in this case it was about 10.
Also gets better networking.
So now you got 10 storage arrays producing the 24 frames per second instead of just one.
Just out of curiosity, what cloud did they move that to, and what would be the next slide?
So I'm going to actually show you some other interesting cloud ones. So it's their choice. So it's just an S3 based. They had given us permission, sort of, but it's one you know.
Well, the reason I question it, and I'm not looking to disparage anybody, but I do know that there are compliance issues with licensed video on Azure right now that they have not yet resolved, and video being a particular use case.
Yeah, this is raw format, right? Of their own video that they're producing, right? Well, their own motion picture content, right? So this is like the big cinema stuff, right?
Right.
And these are individual frames that they're putting up, so they have full ownership of that. In some cases, it's private cloud. In some cases, it's a third-party cloud.
Fair enough.
So it's not actually the same between the two.
Fair enough.
Okay.
Just out of interest, while we're on the M&E
Yeah.
discussion, something that somebody's brought up on Twitter is Nick Howell. He's asking what kind of security features or what do you have in the platform which might help in the scenario of, for example, ransomware, which is becoming more and more common, or potentially somebody coming in and leakage of data, early leakage of movie data, that type of thing. Is there anything in the platform that can actually help to protect customers from those types of scenarios?
Well, I'll give that a similar answer, but I know Douglas is itching to give an answer. I mean, not today, but is there capability? Yeah, with the amount of visibility we have in the infrastructure, I think there's some things that we can do as a company coming up. We're adding those features as folks are demanding, and as a sort of generate revenue for us. That's how we have to prioritize certain features before others. But Douglas.
Yeah, I think one interesting use, and I'll speak to the snapshot copy, snapshot backup use case, is that because you now don't have to co-locate where your snapshot and your data is, we're able to put the snapshot, for example, in a cloud destination. Cloud for us is an S3 endpoint, by the way. Most of our customer conversation is local S3. It's not somewhere in Azure or Amazon. It doesn't matter for us. We're completely agnostic.
You just think cheap and deep, right? It's just slow.
And there's
reliable.
lots of S3 clones out there now these days as well. So you can get cheap on site.
So you could theoretically, to protect against ransomware, I mean, we don't do anything specifically for it, but we lower the cost of storing a large amount of snapshots to nearly nothing. Right, so you're able to maintain much longer snapshot chains with little to no extra cost for you.
Because you're in line though, things like ransomware detection would be actually a really useful and relatively simple feature to include so that you could catch it.
It's possible for us to trigger on things like that, but we haven't done integration yet, which is why.
Yeah, I remember that Disney was in the news. I don't think I ever saw the end of that storyline that someone had captured an entire movie that was just about to come out, into the theaters. And I think somebody was saying that it might have been like Pirates of the Caribbean, but I never really saw any conclusion to that one. And they held it hostage. They were going to distribute it out to the net for everyone
It was
to
that
use.
Sony picture that was going to be about the Korean
Dictator.
president.
Oh yeah, that was.
Was that from that was a few years ago, though, right?
There was
Yeah,
one with
this one
Disney
was very
also.
recent.
Oh yeah.
Recently with
I
Disney.
mean, literally like last 30 days.
Oh.
It was Pirates of the Caribbean.
When you guys take a snapshot, normal snapshots today and normal advanced storage takes on the order of milliseconds to take a snapshot. When you're snapshotting from storage A to storage B, it's not going to take milliseconds.
No, so what happens in a snapshot is we do the metadata snapshot, that's milliseconds, it's really quick, right? We do the file cloning operation. If it's, let's say it's an open file, the worst case scenario, you're writing to an open file. We get the metadata snapshot. Before we allow you to, remember that little layout discussion we had earlier? Before we allow you to read-write access to that thing again, we're actually going to do a file level clone underneath the hood. That's going to copy it locally. What we will do after that copy is done, or whatever mechanism that Array uses to copy or behind the file level clone API, we'll then take the copy of that and move it somewhere else. So the copy, the actual move doesn't. So what we've seen customers do is they keep, let's say, 1 or 2, 3 copies of the most recent snapshots close to where the data is. Let's assume that the data is actually modifying itself, right? And then they move everything else off to cheap and deep. And we can do both.
It's the age snapshots, right? Not the one that's actively being done.
So that way you have no performance impact
another best
on
practice,
the clone
right?
operation. But yeah, no, it's a good question because people ask all the time.
Yep. Next one, exploration production. Like I said, this is for the upstream, and this is really the sort of scientific work to go figure out where are those natural resources in the ground. In particular, the use case here it is for oil exploration. We learned a lot about this space. Customers really educated us quite a bit about it and how we could help them benefit with our technology. But some of the sort of basic things that the data sets are very unstructured, very heavy in metadata, so they collect a lot of information about the data itself. I'll give you an idea what that sort of means. The geoscientist itself, there's different stages, right? They go and they collect data about the space, the land, the field that they're interested in. The scientists have to go run a tremendous amount of analysis, taking that information, try to determine, is this land worth leasing? And it's a fight, right? There's other oil and gas companies that are doing exactly the same thing. And you only have a small window sometimes to make the decision as whether I'm going to lease that land that's 5,000, 6,000, 7,000 feet below water. Right? I mean, if you take a look at the Gulf of Mexico, there's a lot of drilling that's happening all over the place. And when those leases come up and someone's going to make that decision, it's an expensive decision to make. So they have to figure out, do I have all the information I need? I need to run a lot of simulations and analysis and help make that decision. The scientific discovery itself really is completely done in the digital domain. So the data collection is happening right now, and I'll give you an idea of this with some aspects, and I'll explain what the heck this picture in the background really means. When they are first making some consideration, the kind of data they're collecting, and some may have heard like this thing called sort of seismic data that they're doing a collection of. What this picture is in fact a ship that's on the ocean. And those lines that you see that's going from effectively, you can imagine we're standing at the end of the boat, taking a shot out behind the boat. Those lines are actually sensor arrays. And those sensor arrays are dragging behind this boat quite a distance. Underneath the boat is an air cannon. Air cannon goes off. Sound starts heading down towards the floor of the ocean. First wave will reflect right up from the surface. Then there'll be some penetration, and then the second wave will come up. And then thousands of feet back is those sensor arrays that starts collecting that information. Now they also have what they call 40, right? So how much time it takes to pass through some of this, right? Not just sort of the distances and those reflections and so forth. What's interesting about this is that this technology and its resolution has been changing constantly for obvious reasons. The amount of data they collect can be anywhere between 6 and 20 bytes, 20 gigabytes per second. The newer stuff coming online is 50 gigabytes per second, okay? That means when you have to go and map, let's say, a square kilometer of land or seafloor, that's what these numbers are talking about. You're collecting anywhere between 250 terabytes to a petabyte, and that's going to do nothing but go up. When they do drill sampling, they'll take core sampling. This is the very interesting part, is that they will take these core samples up. They actually have, a sort of a temporary drill site, do those core samples. Those core samples stay on site. They don't haul that stuff around. It's a bunch of dirt and rock. What they do is they digitize it. Every square centimeter. They capture that information. Many times, by the way, a lot of this data stays on site until it's needed. Kind of the sort of first early rendition of kind of a private cold cloud. So if it's not needed yet, it stays there. They put sensors down into the drill hole, and they collect data from that. Because they're sitting there trying to figure out, where is that oil? Now, I want you to picture something. Oil is not some big, perfectly round blob sphere that you just poke a hole into and you take it. It's changing awkward shapes. They're not consistent. They're between, rock and. So just imagine this, right? It's like you've got to figure out where most of that oil is and figure out where to go poke a hole in the ground so you can collect it. Interestingly enough, they will go in, do that initial exploration digitally, figure out what's needed. It's a lot of low latency storage. Geoscientists got to move on to the next one. And then the next one, the next one. Okay, they make a decision to lease that land. Now, they got to figure out where to drill that hole. If they're off by even 2 feet, they may not see the oil. So now they're digitally drilling into this stuff, making a decision where we were going to put this multi-billion-dollar rig in the middle of the ocean, and we're going to go poke, a hole in the ground. If they miss, that's a lot of money. Mm-hmm. Other interesting point. Greenfield drilling is not happening as much as you think. They're literally going back to first generation, second generation, third generation oil fields, performing this same type of analysis, taking old data that they have, re-looking at it again and saying, you know what, we missed a pool of oil over here. Let's go drill a hole and take some of that oil out. That's where probably more than half our oil is coming from now, right? So this is important for these guys. So you're starting to learn a lot about the product, and the approach is very simple. We have to start thinking about data tiering, high performance stores, low performance stores. We also have to think about how we're going to move data to the cloud. We don't need it, move it back. And so from a geoscientist workstation perspective, we were talking about this before. They have a logical view of where all their data resides. Right? We provide them the logical view. And then there's all different types of data that they're pulling from, whether it's seismic data or satellite data. I want to point you to the background picture on this. I could do this for hours because the data is really amazing. That is a satellite image of the near surface gravitational differences. Yeah, what? Well, some places it's dense, we're high in gravity. Some place, is less dense and the gravity is less.
Between me and you, I'm much.
Not only doing physical pictures, but they take all this information, combine it together, do their analysis, and then make their decisions and move on. Very interesting stuff. I had more pictures. I could keep showing you some really just interesting stuff. But here's the really cool play. So as Douglas said before, like, we use the DSXs to connect to the cloud. The process that I walked you through, where they got to get their most relevant current data of what they're trying to analyze and make a decision for leasing, is one thing. Okay, so then they've done that analysis and they need to go store it, but they don't need it locally. So what they're going to do is they're going to put it in what I'm just going to call cold data cloud tier. They're going to pull it back in the ensuing months, and they're going to figure out where to go digitally drill now. Now they're done with it. Where are they going to go put it? Well, I put it over on the sub-freezing data side, right? So the question you asked before is also what provider? Well, it really depends for these guys. They've now done tiering over in the cloud. They take data, pull it off from one place, put it in the other. And that's more archival down at the bottom. But keep in mind, it may be like 2 years later or a year later, they're going to pull that data back and say, okay, we need to figure out where else we're going to drill another hole, because there's probably more oil down there.
It's funny, this is the exact opposite use case to the seismic data pulled from earthquake studies. So that data is critical immediately. Then after it's been analyzed in the first 15 minutes, it's useless.
Yep, because it's changing.
Exactly.
Yeah, there's a bit more consistency on this. Yeah, when I learned that there would be like an oil field that's 50 years old, and they got to go back and take a look at it and find out, yep, there's another pocket of oil sitting over here, and they got to go after it.
And these guys are moving a petabyte into the cloud? That's going to
They're
take a while.
moving very large chunks of data. Remember, in some cases, it's their own private clouds they've set up. In some cases, it's public.
Okay, I'm just,
Okay.
the thought right now of paying for moving a petabyte into AWS or into S3,
That's
my,
easy.
my bank account.
Paying to get it back out.
Well,
That's
this
true as
Yeah, it's free to upload, right? That's
That's
why I
a good
said
point.
before, right?
That's
The
right.
people are still trying to learn it. Clearly, you've probably experienced the bite, of misusing a cloud because you thought it was infinite amount of resources that were low cost.
Yeah, so-
People are figuring that out.
I saw clients that sort of went, well, we'd like to get that. Oh dear, what have we done?
Yeah. Remember what we said before? We've said it a few times in a few different ways. There's literally like 3 attributes that we really do generally worry about when it comes to sort of storage. Its performance, and there's like all kinds of attributes for its performance, like bandwidth and IOPS and latency, right? Cost, right? And for us, the last one is reliability. We kind of use those 3 attributes to make decisions, right? And then we can decide whether something should go into a particular type of storage or storage tier. And we're able to use that intelligence to help out the oil company. All right, information communication and tech. I know Douglas will probably end up jumping in because there's really some cool stories about the service providers as they try to figure out what can they do to help change their business model. They got all kinds of challenges. I'd say the most basic one, some of the stories are very interesting, is where they go after a business. They say, okay, well, we know how to sort of deal with this application, highly reliable, a lot of performance. So they go and they buy a bunch of SAN arrays. They go deploy it. They do this test. The customer says, okay, guaranteed SLAs. We're going to go run this test, and 3 months later it fails. They're like, well, they look at each other going, well, what else can we do? And the answer is not really sure, because the amount of data that's got to go put in this thing, it's not that easy to say, well, let's just go throw a bunch of flash at it. So now can you figure out how to make some other different choices? Also give you another concept that's quite interesting, because they're the ones who feed it back to us. The idea of leasing. You would never lease storage, unless of course you lease it for its lifetime. But what if you only needed something for about a year? The effort and work for data migration is gigantic. And for a service provider, that would be ridiculous, right? To figure out all the resources that they can move it off of old to something that's new because the customer's got another requirement. But what if the customer's not making use of all of their storage? Well, then you just over-provisioned as a service provider, and your margins just got smaller again. Okay? These are some of the things that these guys worry about. The biggest thing they tell us is, again, the old Pareto rule, which is most of the data is cold, and they can't get it off, and they can't move it, so they can make better use of their own resources to provide a service for that customer. Big, big problem, right? So they asked us a few things. One, their business was under so much margin pressure, there was some functionality, some storage services that they had to contemplate to move out to third party, because they could not source and deploy and use economies of scale to make it cheap enough. There was always somebody else out there who could offer something cheaper from a competitive perspective. Those are things they had to go contemplate. The second thing is they already knew that they were spending too much money for guaranteed SLAs. They had to over-provision like crazy, spent a lot of money towards that. There was no easy method for them to detect, determine what's cold, and what they could safely move. Those problems need to get solved. I'm suspecting now at this point you're starting to understand our approach is very straightforward. We can actually take, as Douglas said before, we can move storage in, data can migrate to it. We can set a time frame for when we want to take storage out and retire it. So if you say, look, over the next 60 days, 90 days, 6 months, I'm going to retire and shut this storage off. I want DataSphere to start moving data off of it. And when, let's say the warranties or the storage is end of life from the business perspective, on that last day, if you want, all storage is off, you can unplug it and no application is the wiser. This is where these guys start turning around and saying, oh my God, I think I can actually do some very unique services. They can have guarantees on performance now. They don't have to put every single file necessary for a guaranteed SLA on an application, only the ones that are the bottleneck for that app. So now they actually are getting better utilization. We go back to almost my first slide, right? It was the pick any two. The idea was how efficient can you get? That's the name of the game. If you can get better utilization of the investments you do in your infrastructure, your business will be better. Well, the benefits to the customer too. This is what their environment looks like. They asked about data tiering. We haven't talked a whole lot about it, but I think you guys are starting to get the idea is that now you can start creating a hot tier, a warm tier, and a cold tier. 2, maybe 3 years ago, when I was coming into primary data, I was looking up sort of these kind of benefits that we were talking about this idea of data tiering. The idea, the concept's been around forever. And I said, I'm just going to go see, is there anyone who solved this problem outside of a cache? Right? Cache we always know is kind of a hottish-like tier, but it's not consistent. So when I go look, say, what is these, top tier storage vendors, like what do you do for data tiering? And it, quite frankly, hasn't gotten any better over the last 20 years. Right? That's a hard thing to do. You need a lot of telemetry and information what's going on, and you cannot do it at coarse granularity. It's got to be fine granularity, otherwise it's too expensive. From the perspective of what our customer can offer, we talk about agnosticism with the storage type and even clouds. That is a huge benefit for them because now they have choice. And they can actually figure out what is the best thing to put into an infrastructure for one of their customers, whether it be for a limited time or a permanent deployment. And these are the kinds of layouts, and it's mixed environments. We've got some that of their customers where they're running Linux, Windows, and VMs all at the same time in this infrastructure. So when you ask about what can you do with ACLs and with supporting the ability to control who has access to what in mixed environments. These are all enterprise class problems. That's why we had to go solve those first. Very customer generated. This one true to my heart where I first started out is EDA, making chips. And watching that whole industry come up into how to go and design a chip itself. These days it's so commoditized that you can't spend a whole hell of a lot of time, and you sure should not spend a lot of money trying to figure out how to get a system on a chip or a microprocessor design out the door. But the one barrier to entry that's still still troublesome is that if you go through and design this chip and then tape it out and build your first set of wafers and it comes back and it's brain dead, 2 things happen. You just wasted a whole bunch of money on those first set of prototypes. The second thing is you just lost a whole lot of time. If it's an advanced technology, small geometry semiconductor, you can spend 14 to 18 weeks trying to get through the fab, get some parts packaged up, and then power them up to find out that you made a monumental mistake. This is almost the same kind of problem that the oil and gas digital exploration problem has. You got to start making decisions in the digital domain so that you don't waste time and money. In the case of EDA, we break it up into 2 sort of functions, sort of the front-end verification side and the back-end physical design. You got to do your logical design. You got to figure out whether it's going to, it's going to flip the bits and it's going to process the data and it's going to look like a microprocessor with a certain amount of I/O. In the domain, literally almost like a language, right? So these guys sit there, use a language that's sort of C-ish looking like, and it actually is a representation of what the logic that you would implement in a piece of silicon. That front end is heavy in small files, hundreds of millions to billions. Not a lot of large files, but a ton of metadata. 60% of the traffic in the NFS world, which is pretty common for EDA environment, is metadata traffic. Then it's something like around 50% read traffic in files and about 25% in write traffic files. That's a generalization across at least 5 different vendors who provide EDA tools in this space. The back-end physical design is very different. So now you've synthesized into gates, you've placed this stuff in a theoretical floor plan. It's like building a house. You know, you lay down your floor, you figure out what to put your walls, you put your wiring in, you put your plumbing in. It's the same thing that happens in the semiconductor world. You put your gates and your flip-flops, and you have to connect them all up, and then you have to say, okay, now I've got this design. Will it actually meet certain thermal requirements? Will it clock fast enough? Can I get data through it fast enough? And they do all this in the digital world. Those simulations are literally mostly big file sequential reads. A lot of it, okay? So now the question is, how do we deal with it? Well, this first customer, they are a capital equipment company, and they create a lot of semiconductor dies. The first thing we ran into was actually nothing to do with EDA. A lot of departments, a lot of acquisitions have their own departments with their own storage. And what blew us away was everyone had full ownership of their own storage. The amount of over-provision was ridiculous. Even the challenges of, hey, are they really backing this stuff up? Are they, could they move it in the cloud? Could they protect, their data and so forth? They said, we got to get this stuff under control. Can we actually put this into a single global namespace? And the second thing is, once these designs are finished, they got to save all the results, right? So when the die comes back, they're going to compare their simulated environment verification with what they validate on the chip itself. So there is this sort of cooling off and then warming back up, and then it's going frigid cold again, right? This is very consistent, but it burdens their environment. Also, most of the development workflows will dedicate filers for every single stage during the IC development development workflow. Could this actually be combined and so that you don't have, that over-provisioning and that waste? Well, the approach is pretty straightforward, right? Can we actually aggregate for performance where it's needed with all the different NASs that are available? Can we help move verification data to and back, from a lower cost store? But more importantly, this particular customer is working hard to contemplate a self-served environment. We have talked in the past about our objectives, where you can offer a catalog of objectives that an application manager can apply to their environment and get guarantees that this set of files, subdirectory or directory, will have this level of performance. They don't have to specify what storage. They have to specify the attributes, right? Those same ones we talked about before, performance to a level of granularity of including IOPS and latency and bandwidth. How much reliability do I want? Do I care? Is it transient data? We need to know that. Because if you want to put, let's say, transient data into a flash in a server, you don't really care if you lose that data, but it makes your app go faster. We need to know that, and we can actually move that stuff in and out. So their environment, I think this is my second to last slide, it's ended up looking something like this. They have a large capacity NAS array. They actually have taken performance NASs and put them together for performance, and they added a cloud on the back end with a lot of clients, because you have all of these parallel running simulation tests that are actually occurring, generating a ton of data. All right, I got something for you. So what's your problem? How can we fix it? The application is one that doesn't have the understand what's going on, or is it the storage itself? That's what we're here for. That's exactly what primary data is focused on, and where we're actually starting to see our success.